Welcome to our lesson on interior and exterior angles of polygons. Our learning goals for this lesson is to find unknown angles of any shape with any number of sides. To begin this lesson, students were given different shapes. Some were given triangles and quadrilaterals, which are shapes we've already seen. Some were given pentagons, which is a 5-sided shape. Some were given hexagons, which is a 6-sided shape. We also did heptagons, which has 7 sides, and octagons, which has 8 sides. In each shape, students were asked to measure all of the interior angles, which are these. So here we have an 8-sided shape, so it has 8 interior angles. We also extended the lines to make exterior angles and then measured each of those exterior angles. And then finally, we broke each of these shapes into how many triangles that could be formed within each of these shapes. So this octagon here, you can see that we started at one point or one vertex, and we went to each of the other vertexes to see how many triangles that could be formed. So in this octagon, there's 1, 2, 3, 4, 5, 6 shapes, or 6 triangles that form this octagon. Another important concept that we discussed here is the word regular polygon. A regular polygon means that each of the lengths are equal, which also means each of the angles are equal. So here, this octagon looks to be regular because all the lengths look to be the same. We'd have to verify this, but that's what it looks like here. We'll now continue to the next page where we summarized our results from each of these shapes that we looked at. So in this table, for the triangle, we know a triangle has 3 sides. We know there's one triangle and a triangle. And we know that the sum, because we've looked at this before, the sum of all the angles in a triangle is 180 degrees. In a quadrilateral, there are 4 sides. And a quadrilateral we can break into 2 triangles. That's an easy one to show. You have a quadrilateral, start at one vertex. You can go to the other, which is just along the outside length, then the second vertex, and then the third vertex. So you can see 2 triangles. We also know that the sum in the quadrilaterals of the interior angles are 360 degrees. We knew that from last lesson. So the pentagon has 5 sides, and we found that it has 3 triangles, and we found that the sum was 540 degrees. A hexagon has 6 sides. There were 4 triangles, and the sum was 720 degrees. So you might start seeing a pattern form. What you might notice is that as the number of sides increases by 1, the number of triangles also increases by 1. And you might also notice that the angles sum increases by 180 degrees. So basically, each time you're adding a triangle, you're going from 1 triangle to 2 triangles, you're adding another 180 degrees. And then from 2 triangles to 3 triangles, you're adding another 180 degrees. And that makes sense because there's 180 degrees in a triangle. You will also notice that the number of triangles is always 2 less than the number of sides of your original shape. So the quadrilateral has 4 sides, and there's 2 less triangles. The hexagon has 6 sides, and there's 2 less triangles. So using the pattern, see if you can find the number of triangles and the angle sum for a heptagon and an octagon. A heptagon has 7 sides and an octagon has 8 sides. So using the pattern, that would mean a heptagon could be broken into 5 triangles. And then we're going to add another 180 degrees to 720, which is 900 degrees. A better way of doing this is just taking your 5 triangles and multiplying that by 180 degrees. because each triangle adds up to 180 degrees. So 5 triangles adds up to 5 times 180, which is 900 degrees. So the octagon, which has 8 sides, can be broken into 6 triangles. So the total sum is going to be 6 times 180 degrees, which is 1080 degrees. So we could keep going. I could ask you a 100-sided shape. Well, to get the number of triangles, it's just 2 less, 98, and then you would multiply that by 180 degrees to find the total sum. So there is a little formula that we've developed here, and it just says that the sum of all of the interior angles is 180 degrees times n minus 2. N is just the number of sides of your original shape. So the n minus 2 just says the number of sides take away 2. So when it was 8-sided shape, it was 8 take away 2 to get the 6. And then we took those 6 triangles and multiplied by 180. So feel free to use this formula, but you do not have to if what we did up here, this generalization, makes sense. You just always have to take 2 away from the number of sides and multiply by 180. Now, if we are asked to find the measure of each interior angle, so each one, not all added together, but each one separately, in a regular polygon, you would do I equals the same thing, 180 times n minus 2. And this time you would divide by n. I just stands for each angle. So what this means is you take the entire sum of all of the interior angles and you divide by how many angles there are. And this works because only in a regular polygon, because in a regular polygon all of the angles are the same. So again, we have these 2 formulas that you can use, but you don't have to if it makes sense, if the pattern makes sense to you, and you're able to find the angles without the formulas, that's okay. And then the other thing we found is for all the shapes that we had, no matter how many sides they each had, all of the exterior angles always added to 360 degrees, no matter what. So let's do some practice on this page. Here we're asked to find the value of x, which is this unknown angle here. Let's count the number of sides. We have 1, 2, 3, 4, 5. So we have 5 sides. So let's not use the formula. Let's just say that the sum is equal to 3 triangles, because in a 5-sided shape we know it will be 2 less triangles, and each triangle has 180 degrees in it. So we're going to take 180 and we're going to multiply it by 3 to get 540 degrees. So all of these angles in this quadrilateral will add to 180 degrees. So what is the sum that we have so far? So we're going to add the 4 angles that we are given. So add those up, and you should get 469. So to get the unknown angle x, you take 469 from 540, and you get 71 degrees. So this is very similar to how we were finding unknowns in triangles and quadrilaterals by adding the other side, the angles that we know, and taking it away from the total sum. But we had this extra step up here where we had to find the total sum first. You're not expected to memorize that in a 5-sided shape the sum is 540 degrees. And you don't want to have to memorize, because sometimes you're going to be asked for bigger shapes, such as in this next question where we have 12 sides. So here we are asked to calculate one interior angle and a regular polygon. So those words are important. you want in each angle of a regular polygon. So it's a 12-sided shape, which means there are 10 triangles that will be formed. So 10 times 80, or 180, is 1800 degrees. So all 12 angles are going to add to 1800 degrees. Because each one is the same, because this is a regular polygon, this is only true for regular polygons, we're going to divide, and I made a mistake there, not by 10. There are 10 triangles, but there are still 12 angles in that shape. So I'm going to take the 1800 and I'm going to divide it by 12, and I get 150 degrees. So that means each angle is 180 degrees. In B, I want to calculate the measure of one exterior angle. So actually in A, I probably should highlight the interior as well, because we could also be asked for the exterior. And again, it's a regular octagon. Octagon has 8 sides. So there's 2 ways of doing this. One is I could find each interior angle like I did above, because once I know the interior angle and exterior angle add to 180 degrees. So in part A up here, I could easily find the exterior angle is 30 degrees. And I did that by taking 150 away from 180. But that's 1, 2, 3 steps. So I did it this way in part A because I already had the interior. Well, in part B, I'm not asked for the interior, so I don't need to do the first 2 steps. I can simply do 360 degrees divided by how many angles I have, which is 8. Because I know all exterior angles are going to be the same because it's a regular polygon, and also all of the exterior angles add to 360 degrees. And that's just a rule. So 360 divided by 8 is 45 degrees. And in C, I want to calculate the sum, so the total of all of the interior angles in a polygon that has 12 sides. So there's nothing here that tells me this is a regular polygon. So it's not regular, so that means each angle is not the same. And I'm not asked to find each angle. I'm asked to find the sum only. So to get the sum, I know that there's 2 less triangles. So there's 10 triangles in total, because there's 2 less than the 12 sides. I have to multiply that by 180 to get 1800 degrees. And that's it. I'm done now, because this is the sum. I'm not going to divide by 12 because this is not a regular polygon. And that is all the practice that we're going to do in this video. There is another page of practice for you to do, as well as questions in your workbook.